in example C, we want to test this series here, and this is a new one, so we're not really sure what's going on. So we should really check the very first test, which is we want to check to see if the limit as n goes to infinity, it goes to zero. Okay, as the nth term test, we have to make sure that it equals zero. Otherwise, we don't even need to consider that series converging. So that's the first thing that we're going to do, is we're just going to check this series out, the sequence, and just make sure the sequence goes to zero. So when we check this out, the limit as n goes to infinity of sine of 1 over n, and we can work that out. This works out to be sine 1 over infinity, which is sine 0, which is 0. Okay, so this passes our very first test. We now have to consider that this could converge. Okay, so there's my series. I need to then now think of, does it converge? Okay, I need to have a sense, and if it converges, what should I compare it to? Okay, so it's probably hard to figure out, but one of the things that we can maybe compare this to, because we're going to set up a ratio and a limit, is maybe we can set this up with 1 over n. So 1 over n is a diverging series. So that's what I'm going to test it with. I'm going to test with the diverging series. One over n. Okay, and the reason why I'm going to test this is because once I set it up, we'll be able to work out the limit of this fairly easily. So the limit's going to look like this: the limit of the nth term comparing to each other. So I'm going to compare that term. So the limit as n goes to infinity, in the numerator, I'm going to have sine 1 over n. In the denominator, the known series 1 over n. Again, I can flip that upside down if I want, but I'm just going to put my unknown term on top. It's not a bad idea too. So I'm going to then see if I can work out this limit. So I'm going to get sine of 0 over 0, which is 0 over 0, which is inconclusive, but it does establish the condition for L'Hopital's. Okay, so I now have the condition for L'Hopital's, so I'm going to apply L'Hopital's rule here. Okay, so that allows me to do this. So then I get the limit as n approaches infinity. The derivative of sine is going to be cosine times the derivative of 1 over n is 1 over n squared. In the denominator, I get derivative of 1 over n is 1 over n squared. These terms are going to cancel out algebraically, and so we're left with a limit that I can evaluate. So this becomes cosine of 1 over infinity. Well, the cosine of 1 over infinity is same as cosine of 0, which is equal to 1. Okay, so what's my conclusion then? If my limit is equal to 1, or any finite number, a non-zero finite number, my conclusion is this is greater than 0. Therefore, 1 over sine 1 over n behaves like one over n. Okay, we know that the sum of 1 over n is divergent, and from that we can conclude that the sum of sine of 1 over n is also divergent. And there's our argument. So there's our test. The test gives us this conclusion here. Let me just highlight that. Okay. We get this conclusion here. If that is a non-zero limit, we know that they behave the same. 1 over n diverges, sine of 1 over n also diverges.